welcome to another Fusion Friday, or as my counterpart Umer says, Phil Brown breaks it down. This week, we're going to talk about how you can use parameters to build a template file, and then from that template file, build very quick assemblies with variations of that part. This is really, really helpful for anybody out there that's doing woodworking, where we're going to build just a template for a cabinet style. And again, as you could build multiple different cabinets, different drawer numbers, things like that. But how we could take that one cabinet and with a couple of quick dimensional changes, create multiple different variations of that cabinet for whatever your projects might be. This does work very well across a lot of different things at the end of the day. We just chose to go with the cabinet because next week we're going to actually have the guys on from Bomber, and they're going to walk you guys through why Bomber is so important with stuff like this for building your cut list, getting everything organized, your quantities for ordering even you can control inside of Bombers. I absolutely love it. I met these guys a couple years back when I was at Autodesk, and they are out there killing it. So let's go ahead, jump into the software and see how this is done. So we are going to start inside of the design workspace. As you can see here, I'm already in my design workspace. I have Fusion 360 pulled up. And the very first thing I like to do is either start to create components or pilot/test run my ideas of what I'm going to do. In this case, I already have an idea of what I want to do. So in this, I'm going to go ahead and just start creating my components. So the very first component I may want to create here is the face for that cabinet. And inside that face, I may want to create a, left rail, and then maybe a top style. Excuse my spelling, but the idea here is, in this case, I've already made a mistake. Let's go back and undo that. That mistake is because this component was active, it kept stacking them down. I would like to place my rails and styles both under my face plate at the end of the day when it comes to building out this cabinet. So give me one more second here. We have a top style. And then one more we're going to need here is going to be the bottom style. So again, this is going to be kind of like an upper cabinet. If you were to make shelves, drawers, anything like that, you could add additional styles in there to accomplish your task. Again, the idea is we're going to make a faceplate, and this is one of the few times where you're going to see I'm going to use a sketch, not in my individual components, but at the assembly level, and then we can make our rails and styles off of that. So again, let's start by creating my sketch. In this case, I'm going to use just nothing more than some rectangles to do so, to kind of outline what I'm trying to do. And let's get these all set. As you're going to see, some of these aren't perfect at the moment, but we always have the ability to fix stuff, and it's much easier to put my ideas on paper and then come back and add things like my dimensions here, or use maybe horizontal vertical to line up things. In this case, I'm getting an error. That error is caused by the fact that those two lines were a little too close to each other. So I just dragged that up and it snapped into place. Again, if I want to create the same dimension twice, I can actually click the first dimension and the second dimension. Again, a lot of different ways to do this. In this case, we're going to be fancy with this. So let's say my rails are actually my rails verse styles. I apologize for anybody watching that's cringing right now. I am no cabinet maker by trade, so I am just going with this on the fly. Again, if I want this dimension and this dimension always the same, I could use an equals constraint. However, I found it's better just to be able to click that first dimension to cut down on how many dimensions I have showing up. And again, as if we went to a 2.5 kind of outline, again, both update automatically. Let's go ahead and put that to 1.5. And then lastly, I need my height. And in this case, let's do a 30-inch tall cabinet. And we're already breaking things, which we're going to fix here in a second. And I like to start with about an 18-inch wide. So again, if I click and drag that up and it snaps at a point, it should fix those things together for you. So no matter what your height is, as you're seeing here, as I change it, it now moves up and away or out and across based on those two dimensions. So again, we've created this sketch, and we did so at the upper assembly level because we're going to create our individual bodies to place them in our component areas. So again, maybe I need one more component because I need a right rail so that we have everything set. So now I can go through and I can start to extrude my different items. Again, I'm going to just start at the top and work my way down. We're going to say extrude this one. Maybe these are all 3/4. Let's go 3 divided by 4. And now my sketch has disappeared. So we can go ahead and turn that back on, go to our top, and basically rinse and repeat as needed. So again, give me a second here. I'm going to wrap these all up. I'm going to show you guys all another way you could design this. However, it's not so much important how you design it or which way you design it. At the end of the day is when you're still getting the same results at the end, and you'll see where we start to tie dimensions together with parameters here. That's the key element to everything and anything inside of this. So again, I have my upper, my lower, my left, my right, all driven by one sketch. Again, if we go down to our timeline, so I'm going to go ahead and go back to my top level. We can see that sketch. If I change anything inside this sketch, it's going to automatically update everything and anything based on my drawing. So let's say we go 24 by 20. I hit finish. All of my extrudes came after the fact. As you can see, that cabinet is fully controllable. Another kind of super neat trick, if you're somebody that wants to see your dimensions on the fly, you could always go to your sketch and say show dimensions, which also allows you to edit these in real time based on what's going on. Again, when you turn your sketch on and off, those dimensions will disappear. You don't need to keep going in to edit those sketches. So we made our faceplate. Now we can go ahead and create the sides, the back, any other additional information that we need. So again, I'm going to go up to my top level personally. I'm going to create a new component. And again, this is going to be, let's say, right side. And then I'm going to create my sketch on the side. So here, the idea is again, we're just going to use nothing more than a couple of rectangles to create that side feature and kind of our little toe kick area. So a few things that we want to do is we want this actual shape to be automatically controlled based on that faceplate. So again, as I'm using a coincidence to set the front, I'm going to normal dimension with a hotkey, the depth, and the recess portion for that kick plate. And again, lastly, I need a total depth of my cabinet, which is why I'm pulling my dimension from the front face. So we have 22 inches. Let's just round that down and get that set. So one major thing that we're going to see later is if I go ahead and highlight this dimension with my mouse is D15 plus our faceplate is technically our total height of our cabinet minus countertop height. So this is something that we can also do some math with in that parameter table to really set this up for success. So again, as I'm going to go ahead and finish my sketch. In this case, a lot of people actually ask me about this is, well, what if we're going to put dowel pins in there for shelves? Again, I can go back to that sketch. I can create my dowel hole pattern. In this case, I'm just creating 2 holes. I'm going to go ahead and line both of these horizontally. I'm going to make them both equal. And then let's say they're 1/4 inch dowels, so 0.25. And then again, you guys could go through and dimension this as much or as little as you want. Again, I would possibly pull dimensions from top or bottom to get them set in here square. How far are they going to sit off the front? Everything and anything at the end of the day. And now we can extrude our cabinet side. So again, I'm going to go ahead and grab all my points of information. We're going to pull that in. As we can see, that's going to be a negative number, and I'm going to go with a 1/2 inch thick side piece. And again, our sketch has disappeared, so we need to go turn our sketch on. And now I want to add my dowel pins to this. So again, I'm going to do another extrude. So I'm hitting the wrong hotkey because it's a little early in the morning. And because my sketch is on the outside of my part, we could do a 2-sided extrude. My first side here, I want to start on the inside. My second side, I don't want it to go all the way through. So again, I can actually start that based on that 1/2 inch, and then I could change that dimension accordingly. So I'm actually going to go 375. Oh, I'm backwards. An 1/8 inch, 0.125. And again, that is going to be off the inside. So we have a little 1/8 inch here on the outside, maintaining those actual extrudes. So what does that look like? So there's our first set of dowel pin holes. I would like to repeat that down so that you have an adjustable height cabinet drawer in there, or a shelf, so to say. So let's go ahead and do a rectangle pattern. This is, again, another kind of trick that a lot of people don't think about, is I can actually take the feature itself and I can pattern that. So again, as I want that pattern vertically, let's say I want to do, 8 sets of these across, 12 inches, for example. Again, you could do this based on an extent type or a spacing. Again, if I want 8 spaced out by 2, again, fully customizable, right? So as you can see, when I first drew my faceplate, I did everything with that idea of having each one as its own kind of separate entity and then extruding them one by one. On the case of the side, which would also work with the face, I could actually utilize the mirror function to be able to mirror said component. So what I'm going to go ahead and do is I'm going to grab my right side, and I need a mirror plane to go across. And in this case, as you see, the only actual plane I have to work with right now is my center origin plane that we pulled everything off of. So let's go ahead and cancel. Let's go back and create our own mid plane. And we can create that mid plane based on the left and the right side of our faceplate. And then we're going to use that actual plane for our mirroring. So again, is why we're going to go ahead and pull that component. We're going to go ahead and use our center line to mirror our left and our right and hit OK. But the nice thing is you now have your right side and your left side. And again, these are ambidextrous parts. So when we mirror them, you're going to notice that all of our dowel pin features have come through, again, from one side to the other, making life extremely easy for everything and anything that we do. So I did make a mistake here, if you guys didn't notice, is I forgot to do my toe kick down at the bottom. Again, very forgiving in the software is I can go to my timeline when I extruded that. In the event that I can't find it, my timeline easy, if I actually click my part, it also highlights it down here in the timeline automatically for me. So I'm going to go ahead and double click that. Holding control, I could add that second segment or second body into what's going on. And again, because the downstream effect was to pattern that at some point, you can see how this is automatically patterned across my part. Again, making my life simple and making all these tasks very easy to do. So again, a lot of this is rinse and repeat, guys. It's all about your organization and your components. We'll do this one more time. We want to go ahead and do the back panel. Again, I create a sketch based off the backside of one of my sides. Again, I'm going to need to project a point possibly. So I'm going to go ahead and project that corner. And now I can go corner to corner with a rectangle. You're seeing me use a lot of outside type stuff. So I may need to actually set and back up a step, remembering that I need that to go between my two side panels. So again, is maybe we get a little fancy with this, right? So instead of using that dot down there and being very quick with this, let's go ahead and project the inner edges on the backside. And then let's say we're just going to put a simple support across the top. And then I like one across the bottom, just a couple inches up. So again, some hotkeys I'm using, D for dimension. We could use the equal constraint here to make these two the same. Very customizable and very easy to set up at the end of the day. So again, we grab those two, -0.5 to create that thickness. And now we have that upper and lower kind of chain, utilizing that for our width or just some supports in the backside of this cabinet. Again, I'm no expert, guys. I'm just trying to build out what we commonly see and replicate that. So again, at this point, we're going to go ahead and turn that construction line off for center. We have one that was copied over when we mirrored everything. And let's go back to our top level. So at this point, you guys might add more detail to this. The idea here is to give you a very sound foundation on how we can go into our parameter side of things. And let me go ahead and pull my parameter table in. And now we can start to set some of our own parameters. So again, as you saw me do, is we have these different dimensions here. So I do like the idea of some of these dimensions being used. or how we could do math with those. So again is, let's create a user parameter, and I'm going to call this cab H for cab height, and I would like a total height of 32 inches. Well, if you remember, based on everything that we've done is, again, we have our right rail, or actually not our right rail, but our right side. We have that sketch. And again, remember how we said there was a certain dimension that we wanted to control. I don't remember what that dimension is, but if you just seen there, I changed 1 from 4 to 6. We see that entire toe kick goes back. So again, we're going to go 5 versus 4. There we go. So we want our actual 5-inch side, which is our height. So we want to use dimension 15 to control dimension 5 at the end of the day. So what we're going to do is we're going to say this is cab height minus dimension 15. And what is happening now is it's taking that 5 inches away from our actual 32, which leaves us with 27. So now we have a true height cabinet of 32 inches. Again, you can make another user parameter here for cab width. Nothing here is super fancy at the end of the day, guys. You could do this as much or as little as you want. Let's go ahead and go to 24-inch wide. Let me go ahead and cancel that. That one was being a little funky. So we're going to go ahead and go cab width. And we want that to be 24. It was not actually being funky. It was myself being funky. Again, we go down here to where our cab width is. I go ahead and type in cab W. I click out of that, and now my cabinet expanded out. This is the cool thing with the parameter side of things, is this allows you to set any and every dimension that you've ever wanted and be fully controllable. Again, cab depth, let's say it's 18 inches. And now we go down to that portion. Cab depth, and again, now our cabinet is 18 inches deep, 24 inches wide, and 32 inches tall. Again, I know this may be a little confusing, or my credibility has gone out the window. You would never put a toe kick on a cabinet that's being hung up on the wall. I get it, guys. I just want to give you some quick scenarios that is going to make your life much easier when it comes to designing these different things. So now that we've done this, we could actually save this file as a cab template, for example. And the idea is this is something we can pull in later and use to build assemblies. So let's go ahead and do that. Okay, now, so I've built my template cabinet. You may have multiple template cabinet kind of setups based on what you guys do at the end of the day. And again, you can still make drawers, you can add your hardware to these things, everything and anything. But now let's think in the concept of, I want to place a couple of cabinets in a kitchen or something. So what I'm going to start by saving my actual file. So we're going to go ahead and call this kitchen. And then what I'm going to do is I'm going to open my data panel and navigate to where my template file is. So what's going to happen is I can drag and drop this guy in. And what you're going to see is that's going to come in, place itself in the origin or the foundational spot that we started with. And again, as if I was using a couple different style cabinets, I could bring those all in one shot. But the idea is once we get these in here, we're going to break this link because this is not going to be a template that needs to be maintained by the original file. We're actually going to modify this all on the fly. But as you can see now, I have cab template version 1.1. So the idea is if I wanted two of these, the exact same, I could just copy, and then I could do what's called a paste. And then I'm going to manually slide this over. So what you're seeing now is we have V12. So what's happening is these two are still technically bound together with their dimensions. So when I change one, the other one's going to change. So if I needed two identical cabinets for my layout, this is how I could do so. Again, it's just a copy of the original and a paste of the original. So now if I go ahead and do a copy, paste new, what you're going to notice is it's going to give me a whole nother naming convention at the end of the day. So now I have parentheses 1, 1, right? And again, as if we copy this guy. And again, I'm going to just do Control V. We're going to go ahead and capture that position because we want to keep these all spaced out. And again, now we have 1 versus 2, 1 versus 2. So the math on this is relatively simple. We have two sets of two identical cabinets, right? So that being said, what I can now do is when I go to my parameters table, what you're going to notice is any of your parameters that you want to control, I can go in and control based on what's going on. So here's where the fun begins. So all of my parameters here are you're going to currently see, even though we're jumping across two different sets of cabinets, they're all tied together. So again, as if we go to a 28-inch width, everything changes. If I want a 20-inch wide cabinet, as you're going to notice, some of these are going to break because we didn't do joints to join them together. But the idea is still the same, that they're all changing based on certain parameters. So I may need to go in and plug in a couple different dimensions. Again, if I create my own dimension here, we're going to say cab width 2. Again, I want these guys to be 20 versus 24. And now I can navigate to where those actually rely. So again, as I go to my face, I go to my sketch. Here's my cab width. We want to upgrade this to cab width 2. Again, I hit OK. And in this case, it all jumped. So let's go back in and change my parameters real quick. So again, as these over here could be, 30-inch wide cabinets. My other ones are, 24. And what you're seeing happen is I'm now controlling one set separate from the other. So again, is all my depths stay the same unless you are working in a kind of strained situation, right? All my heights can stay the same, so my cabinets all align and I have the same countertop across everything. But lastly, I can control the width of one set of cabinets different than the other. So again, how you bring these in and how you actually duplicate these out can also affect anything and everything. However, at the end of the day, as you can see, these items are fully controllable with everything that you do. Again, we could always roll back our timeline if we wanted, and we could make some changes to this also, making our life equally as easy. So again, as if I go back, for example, from when I brought in that second component. So again, we're going to go ahead and see that that component's actually hidden in the background. So let's go forward one step. And we may need to go a couple of more until they move and adjust that. But you could always rigid group these to keep them from breaking, as you're kind of seeing happen when you add your dimensions. Again, I could rigid group these at a different level, but the idea is still the same, that when you go in now and change your parameters, your entire cabinet should stick together, which again, mine is not sticking together, guys. I understand. And we're getting kind of out of time on this video. The idea here is, again, this is a fundamental idea to be able to use a template file and create things. So in this case, we create a kitchen. We use that actual kitchen cabinet to create a template, and then we use that template to fire off as much as possible. This works with a lot of different design ideas, or almost like a similar family of parts you could actually set up to be controlled with a parameter table. As always, guys, thank you for another Friday. I hope this is helpful for a lot of you on how to do things. Don't forget to subscribe to our channel next week. We're actually doing a live demonstration of ProdSmart, or not ProdSmart, I apologize, with Bomber. And they're going to show you how we can actually take a full kitchen assembly and bust out all your cut lists and everything and anything to make your job much easier when it comes time to actually build these cabinets. As always, don't get drunk on work. Have some fun over your weekend before you start your Monday. And always like, follow, and subscribe to continue getting content like this.